the Thursday before spring break, you took the 7-1 to 7-2 test. That went really well for everybody. The scores are in. Then the Friday, I had the digital lesson for you on the MCA practice day 1. Some of that, if I'm remembering right, a lot of it was just review. Did you remember stem and leaf plots? That's what I wanted to ask. When stem and leaf plots were on the video? Been too long since prob and statistics? Okay, so that's the reason that we're stopping to go over MCA topics right now. And it's not just for the MCAs, obviously it's also for the ACTs. But the probability piece in here, get a little worried that maybe you've forgotten some of that probability. So I need you to grab your packet, MCA big packet. You just had one. Mine are separated into day 1, day 2, and day 3, but should be a packet that says MCA practice on it. There we go. Yes, and this you wouldn't have had because we didn't know if people were going to have to take the MCAs when the semester started. Yeah. Sorry? Oh, yeah. Even if you're not a junior, it's really, really good practice. In fact, some of my pre-calculus students said, Cedar Homer, are you going over some stuff with your Algebra 2 students for MCA practice? And they actually asked for these, because it's been a long time for them too since they've seen all this, and they have to test on it as well. Anybody else that packet's not there where you thought it was? Okay, now, as we go through this one, we're going to need the calculator today. So if you have a graphing calculator, grab that, get it out on your desk. If you don't, get your Chromebook up, go into Rapid Identity, and get that TI-84 app. Because the MCA's totally done on computer now, and it actually pops up the TI-84 Plus as the calculator when you need it. So whether or not you have your own or not, you're going to be able to do just fine with the calculator portion. I'm just going to hang in here until I make sure everybody has calculator of one form or another ready to go. Okay, we good to go? I know some of you have it on your phones too. Alrighty, so here's MCA practice day 2. And hopefully, as you look at this list, you think, hey, I've seen all that stuff before, but it's a matter of looking at it differently now that we're going to be talking about what you'll see on the MCAs. So, we started the year with equations for lines, and that's something that you did way back in, would have been exponential. Even before that, back in middle school, you were writing equations for lines. Line of best fit, that we need the calculator for. We want the calculator to tell us what's the line that's going to work for all this data. Distance formula and midpoint, it's probably been maybe in a couple of review problems in Algebra 2, but mostly that's geometry, where you're using the distance formula and the midpoint. Parallel and perpendicular lines, we did that at the beginning of the year this year. Graphing inequalities, we did that. Functions, we did that. Simplify exponents by division, we did that. And then, this is the one we couldn't get to in time for the test. Geometric sequences. So I'll talk a little bit about that, show you that it's not the toughest thing in the world, and yeah, you probably could still get it right, on the MCAs, even with just this little bit of information. So example 1 says, write an equation for a line with a slope of 3/4 that passes through the point -4, 6. And I think about the beginning of the year, and I remembered that the names of the formulas really told you what they were for. So this one has a slope and a point, but there wasn't a slope-point formula. How about if I turn that around? Point, slope. Yeah, there was a point slope formula, and it looked like this. Write that formula down. They give you a formula list for the MCAs. They don't give you this one. For whatever reason, I think it's really silly because they give you y equals mx plus b. Like, people don't know that one, you know. But this one, you have to know. So this one is called point slope formula. Now, we have to leave the x and the y alone. They're part of the formula. But we have to find things to put in for x sub 1, y sub 1, and m. Well, those things are the point and the slope. M is always slope. So our 3/4 is going to go right here for m. And then this is the x coordinate, and this is the y coordinate of the first point, the only point that they gave us. So that'll go in for x sub 1 and y sub 1. So you just slowly go through and say, okay, y minus, let's see, they gave me a 6 equals, slope was 3/4, x minus, well, that'll be a -4, but if I'm going to put a -4 in there, that's going to become x plus 4. So I wrote that step down, but most of you would probably just go right to this. And you look down at all the multiple choice solutions on your MCA test, and that is not there. Now, it might be, and you might be able to say, whew, go on to the next problem. But it's also possible, because they do this a lot, that you look down at all of the answers and they look like that. Now, why do they do that? Because they want to make sure that you use point slope form, but know how to make it look like slope intercept form. And like I said, we did this at the beginning of the year in Algebra 2. So we learned we have to distribute our little fraction of 3/4. 3/4 times x is 3/4. Then you take 3/4 times 4, which is 4 over 1. And you'll notice the 4's will cancel right out. And you'll get 3. And then you're almost there. And all you have to do is add 6 to both sides. And then you'll see your answer down there for the multiple choice. So sometimes they stop right here, but not very often, because they want to see, do you know how to manipulate all those numbers and get them to do what they're supposed to do? Alrighty. So this one, I want to hear much more from you guys on. Write an equation for a line with a slope of -1/3 that passes through the point -2, 6. So best formula would be what? Point slope, exactly. Here's a point, here's a slope. And we just have to remember it's y minus y sub 1 equals m times the quantity x minus x sub 1. Okay, so help me out here. Left-hand side. John, put the phone away. What will this look like on the left-hand side of the equals? Good. Y minus 6. How do we start the right-hand side? -1/3. And I want to know what's going to go in the parentheses. Good. Just putting that negative in and immediately saying, I'm just going to do x plus 2. You look down, all the answers are y equals mx plus b form, which is slope-intercept form. So what do you do first to make yours look that way? Distribute that little -1/3. So now this time we have to take -1/3 times 2, which isn't quite so pretty. But with fractions, you just do top times top, bottom times bottom. Or maybe you just do the whole thing on your graphing calculator and hit math number 1 and let it tell you that that's -2/3. Either way, you're going to get -2/3. What's the next step? Add 6. And again, maybe you just grab a calculator and do -2/3 plus 6, math fraction number 1. I'm going to go ahead and change this into thirds, because right now that's a 6/1. And in order to add or subtract the fractions, I need a common denominator. So I'd have to multiply 1 by 3 to get 3. 6 by 3 is 18. So I'll have -2/3 plus 18/3, which is 16/3. And that, you see, that's one of your answers on there. Going to be able to remember point-slope form? The nice thing about these, I don't know if it's nice for the juniors, but the nice thing is really you take the ACTs a week from tomorrow already. Yeah, a week from tomorrow. And then within another week, you take the MCAs. So hopefully those formulas will stay kind of fresh in your mind. All right, so this is the one I definitely wanted you to have a calculator for, because this one says write an equation for the line of best fit for the following data. Now, if we were going to do this by hand, we would graph all of these, and then we'd try to draw a line so that it was about halfway between all of the points. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9 points, about 4 points above and about 4 points below. But this one is asking for the line of best fit. And we could take a little brain break on this problem if we remember that our calculator does all of this, does the whole thing. So I'm just going to grab this piece of paper here so that I have the data. And I'm going to go to my graphing calculator, and I'm going to try and remember, where do we put data points into our calculator? Y equals? If we have a line, we can do that. We don't have a line yet. We have to put in all these data points in here somewhere. Has it been too long? Anybody remember where data points go? Data points are statistics. Does that help? Stats button. Yes, stats button. Just by the left arrow button there and down a little bit, stats. And we want to edit because we're going to put some numbers in here, so that's number 1. And I see list 1. I'm just going to put all the X values in there. So 2, enter, 3, enter, 5, enter, 7, enter, 9, enter, 10, enter, 11, enter, and 13 and 13. But those are just X's. So now I have to arrow over to the right and put in all the Y values. And make sure you use negative, not subtraction. -5, -6, -4, -2, -1, 0, 4, 5, and 6. Now, since it's a test question, and I'm totally handing this over to the calculator, one thing I better do is double check and make sure that I put all the numbers in right. I didn't accidentally hit a decimal instead of a negative, you know, anything goofy like that. So that looks good. And now I have to remember, how do you tell the calculator you want it to give you a line of best fit? Well, it's still stats. So let's hit stats. And now we want it to do all the hard work, and that would be calculating. Notice right up here in the middle, C-A-L-C. Well, it could be one of two things. It could be calculus, or it could be calculate. Let's take a peek. Right arrow once. One of those is the one that we want to use for our lines. Now you're going to notice they don't do mx plus b. They do ax plus b. That's number 4. It's called linear regression. And that's where you get your line of best fit. So we hit number 4. And now this one is a newer calculator, so it gives me this list that I have to go through. Some of you that have the older ones probably won't see anything here. If you just hit enter, you should be okay. But this one asks me, am I using list 1 and list 2? Do I want to worry about the frequency of the list? No. Do I want to store anything? No. I'm going to go all the way down to calculate. And there it is. So I would look at the answers, because this is saying this is my slope that goes in front of x, and maybe they went to hundredths. So I'll only be able to tell that by looking at the answers. Hey, did they go by tenths? Did they go by hundredths? What did they do? And then I can use that to write my own and match it up with whatever they had. They always have one of those on there. They want to know whether or not you know how to use your graphing calculator to do something a little bit more complicated. So what button was the key for all of this? Stats. Maybe write that down next to it. You know, that'll help you think, okay, what was that again? And every once in a while it gives you that little visual. You know, you'll take the test and you'll go, wait a second, didn't I have to write stats over there on the side of this? So good problem for us to see before we take that test. Alrighty, number 4, example 4. Find the distance from negative 7, 9 to 3, 8. Ooh, that requires a little memory work. Except, they do give you this one on the formula sheet. You get a formula sheet. In the past, they've had us actually hand them out as paper. I would not expect that this year. They probably will have a little tab or something that you could click on that'll give you the formulas. But the formula for distance, hopefully when you see this, your brain says, yep, I remember that. You find the difference between the two x values, the difference between the two y values, square them individually, and then add them. And then finally take the square root. So what we can do is say, well, this is the first point, so I'll call that x sub 1, y sub 1. And this is the second point, so I'll call this x sub 2, y sub 2. And then you just carefully substitute it in and follow the order of operations. So this one will be 3 minus a negative 7. Again, if you want to just write plus immediately, write plus. Squared plus, and then we'd have 8 minus 9 squared. Now, like I said, following the order of operations is really important, and we have parentheses twice. So you'd have 3 plus 7 is 10 squared, and 8 minus 9 is a negative 1 squared. Now notice how I put the negative 1 in parentheses, because if I'm going to use a calculator, that's really important that I have negatives in parentheses. But I wouldn't use a calculator for this one anyway. 100 plus 1, square root of 101. And then I check the answers. Did they give it as perfect square roots, or maybe they just gave all the answers as decimals? Well, then you can punch it into your calculator. We've got a square root button on the calculator. Oops, I still have the marker in my hand. So second square root 101. So 10.05 if you see decimals for answers. Why don't you go ahead and do example 5, and let's see if we all end up in the same spot. And let's just leave the answer perfect. So far, so good? Okay, now, you look down at all the answers. And that answer is not there. And you notice, hey, they simplified some of these answers. So let's see if we can find a perfect square that'll divide evenly into 104. Anybody have one? Well, the smallest perfect square that would be under 104 would be 100, but it'd be silly to try that. We know 100 doesn't go into 104. So then we think 81. Nope, that's not going to work. 64? 49? Nope. 36? Nope. 25? No. 16? Some of you have already tried these. What did you get down to? 4. All the way down to 4. 26 times. So you have 2 square roots of 26, and now you look down at the answers, and oh yeah, that one's there. Got it. More likely you'll probably see decimals, but it's a maybe, so talking about it doesn't hurt. This one, I don't know why, but people always forget the formula for midpoint, and this one they don't give you, because they say midpoint. Mid should tell you what you need to do. Mid, what word do you think of when I just say the prefix is mid, M-I-D? Middle. So in the middle, how do you find things that are in the middle? You find the average. You add them and you divide by how many there are. Well, that's what we have to do. We have to average the x's, and then we have to average the y's. And then we simplify them. So 5 plus negative 1 is 4. 4 divided by 2 is 2. 12 plus 8 is 20. 20 divided by 2 is 10. There's the midpoint. So again, that's another one where they say, they should know this one. You know, just think middle. How do you find middle? So go ahead and do example 7. Find the midpoint for that one, please. So what was your ordered pair at the end? Piece of cake, right? You just have to remember the formula. That's all you have to do is remember, add them together, divide by 2. Add together, divide by 2. All right, like I said, this we did at the beginning of the year. You spent probably the most time on it in geometry. So it says find an equation for a line parallel to the line y equals negative 3x minus 5, but through the point negative 1, 7. So now hopefully your first thought is, wait a second, how do you know stuff is parallel again? How do you know if two lines are parallel? Their slope is the same. Did they give us a slope? What slope did they give us? Negative 3. It's right here. So they kind of hit it, but it's m. So we're supposed to use a slope of negative 3. And then they told me it has to go through negative 1, 7. So what formula should we use for this? In the end, what do we have? What's this called? A point. There we go, point slope. So start with point slope. That's why that's so important we talk about that one before you have to take these tests. And put the points in, just like we did earlier. So it's possible that they'll stop right there. But it's also possible that they'll make you keep going and put it into slope-intercept form. I have y equals 3x plus 4. Everybody matching up? Okay, good. Now, parallel is easy to remember, right? They have to be the same. I mean, you think about that, and yeah, it makes sense, because I actually saw a couple of people doing like this with their hands, showing, the two lines. This one says perpendicular. That's a little tougher. So I think, well, it has to be about the slope still. The slope of this one is negative 1/2. But it seems to me there was something I had to do to that if I'm going to do perpendicular slopes. Anybody remember? Reciprocal and the opposite. Yeah, it has to be both. So we have to remember, not only do you have to flip it, but you also have to put another negative in front of it. So this would be 2 over negative 1, but then we'd have to throw another negative on, so that would make it positive. So the slope of the perpendicular would be a very lovely 2. Now, did we write an equation for a line yet? So what formula do you suppose we should use to write that equation? Exactly. Overwhelmingly, you should be using point slope formula. Tons on this test. All right, so here are x sub 1 and y sub 1. There's the slope we want to use, which is a 2. Go ahead and write it. Look up when you're done and make sure everything's going well. Stay with us here. Be trying these. You feel like your memory's starting to come back on some of these? Yeah, I don't know that it would have if we hadn't covered this. So it's one of those things where we definitely want to see these again before you guys have to take any of the tests. Some people are writing frantically. So now we're going to look at a problem that we didn't tell you earlier in the year could be done with your graphing calculator, but it can. So for the ACTs and the MCAs, you could take a little brain break and just punch these into your calculator instead of having to do them by hand. Anybody need more time with this one? Graphing inequalities. Your calculator, in almost all cases, will do this for you. But we don't tell you that because we want you to follow all the steps that you're supposed to do this by hand. And in case you don't have a calculator available, that you'd still be able to graph them. So what you have to do in order to put this in the calculator is have it solve for y. So no matter what, you're probably going to have to do a little bit of algebra. This one is ready to go, but this one isn't. So I'd have to subtract an x from both sides, and then divide by 2, and make it look like y equals mx plus b, like so. Now, here's another reason we don't teach this necessarily when we go through it the first time. Every calculator is different. So some of you have some older ones, some of you have some newer ones. So let me give you, and those of you that have like the TI-83, the really old ones, it won't do it. And the TI-84 won't do it, but the TI-84 Plus will. So we want to graph these. Now, if you have a newer one, in fact, newer than this one up here, if you go into y equals and you hit the left arrow all the way over here and press enter, then it's going to ask you, do you want greater than, less than, whatever it is. For most of the calculators out there, second quit, you have to go into the apps. It's actually an app that came with your calculator. And apps are right next to the math button. So if you hit that one, now I'm going to have a ton of them because this is the, TI simulator for the smartboard here. You will probably see 3 or 4 of them if you have your own handheld calculator. The one we want is called in equals for inequalities. So we have to go down a ways to get the I, in equals. And enter. And now that's turned on an app which will graph inequalities for us. So if we go into y equals, everybody see how below these now you have choices for what you can make it do? How to get those to work is by hitting, I better grab my handheld so I can tell you about these. The little graph buttons that are below these. Like the equals is below the y equals button. So if you want equals, you use y equals. Less than is under the window button. So you'd have to hit window in order to get that to show up. Less than or equal to is under the zoom button. You just use the graphing buttons. Are you guys able to see it on the Chromebooks? Oh, they don't give you inequalities? Okay, did you try the y equals? Now arrow all the way, so use this arrow to go all the way to the left. Now hit enter. Rats! So they didn't make it available to you on the Chromebooks. Well, then I'm going to show you how to graph with my hand in a minute anyway. All right, so what did I need? I need y is less than or equal to negative 2x minus 5. So that means I want this one. And I'll have to hit zoom. Shoot, I'm not going to be able to demonstrate it up here either, am I? Because of the weird way this is going. Yeah, it won't let me choose them. Rats. Well, those of you that have it, you can go ahead and press those buttons. And then what you'll have to do is arrow to the right once, and then you can punch in negative 2x minus 5. And it actually does the dashed or dotted line, and it does the shading for you as well. So that's how it works. If we don't have that available, which it looks like your Chromebooks are not going to let you do that, here's what we do. We remember that we have to start by putting on a boundary line, and that's in y equals mx plus b. So this line would start at negative 5 on the y-axis, and then we'd use that slope of negative 2 to go down 2 and right 1. And I'm actually going to use it backwards a couple of times because straight lines don't happen very easily on the smartboard. And then I have to figure out, should it be dashed or solid? And this one's going to be solid because it does have an equals bar. And then we have to figure out which side to shade on. Well, if you do y equals mx plus b, if this is less than, you shade below the line, and if it's greater than, you shade above. So this one will have to shade below. And then we need to graph the second one, and again, use that y equals mx plus b. So this one would start at 4 on the y-axis. We'd use that slope of negative 1/2 to go down 1 and right 2. And I'll use it backwards to give me something to aim at. Should that one be a dashed or a solid line? That's dashed because it doesn't have an equals bar. Should I shade above the line or below the line? Yeah, above, because this is greater than. Now, see at home, how are they going to do that on the ACTs and the MCAs when just about everything is supposed to be multiple choice? Here's what they're going to do. They're going to ask you which point is a solution, and they're going to give you a bunch of points. And you have to know where the solutions are. Does anybody remember where the solutions to this system are? Henry? Good. Both shadings. So blue and red. Well, that's only going to happen here. So they'd have to give me a point like negative 10, 10 that I could see is where that double shading would happen. So that's what we have to do. Those of you that were using the inequality app, everything work out okay? After a while, it gets really annoying that that's turned on. So then you're like, well, how do I turn it off? I don't want to have to change them all the time. Well, you go back into apps, and you pick inequalities again. And then it'll give you choices, and one of those is quit. So now when you go back to y equals, you won't be able to make those choices anymore about less than, greater than, and all that good stuff. It'll just be equals every time. All right. Take a look at the top inequality. What would we want to do to that so we could graph it easily? X first. What next? Divide by negative 3. Bless you. Now, that brings up something we have to do whenever we multiply or divide by a negative with inequalities. Anybody remember? Bless you if I didn't say that already. We do have to flip it. We have to flip the sign, switch the sign. So it was greater than or equal to. Now it's going to be less than or equal to. Let's go ahead and graph that one. So help me out. Where does that graph, where should I start the graphing for that? Where do you begin your graphing? This one right here. And the y-intercept is what number? Negative 3. How do I get another point on that graph? I'm pretty sure that's an equation for a line. Use the slope. Down 1 and right 3. I want to go backwards a couple of times. So was that one dashed or dotted? Because I know you're already on to the next one. Dashed or dotted? Dashed or solid? Solid line. Did you shade above or below? Below. Y is less than or equal to. Hey, the other one's already, isn't it? Starts at 5. Slope of negative 2 over 1. So down 2 and right 1. Dashed or solid? This one's dashed. Shade above or below with that one? It's this one right here. Shade above or below? Below. So again, down here is where all that double shading is. They're going to give you a list of points and say which of these is a solution. So before you flip the page, are points on this dashed line actual solutions? Nope. That's just a boundary line. On the solid line, yes, those are actual solutions, but not on the dashed line. All right. Now this stuff we've been talking about recently. 2 tests ago? 3 tests ago. Does the following table of values represent a function? A 50-50 chance. No? What's wrong with it? You're thinking right, but backwards. Right. For every input, there's supposed to be how many outputs? 1. Right here, there's a repeater. Anybody remember, if you totally forget, for every input there's exactly 1 output. There's another way to test these. Anybody remember? You could, yes, the vertical line test. You could graph them and use the vertical line test. It would take you a little bit of time, but the MCA is not timed, by the way. However long it takes you to finish it, that's how long you get. The ACTs definitely have time limits. Alrighty, take a look at this one. Does the following table of values represent a function? No repeats in the x's, so we're good? Yeah. Every input has exactly 1 output. This was on the 6-4 to 6-8 test. Did those exponents show up okay? Yeah, because that green is awful. So now, if it's already 1 fraction, most people would probably just do some canceling. Say 3 goes into 3 once and into 6 twice. I have x to the 3rd on the top and x to the 4th on the bottom. So if I canceled 3 of them out from the top and the bottom, I'd be left with 1 x on the bottom. For the y's, I could take 1 y from each one of those. And for the z's, I could take 1 z. And then just collect it all back up, because with fractions, it's always multiply everything on the top, get an answer, multiply everything on the bottom, get an answer. So y over 2xz. Why don't you try the next one on your own? Sorry? Oh, when you cancel, it's like dividing. So, like if we're saying 3 divided by 3 is 1, x divided by x is 1, those type of things. So the 1 is just there as a placeholder. Well, they don't look at your work at all for these tests, for the ACTs or the MCAs. So one way or another, they're just checking your answer. That's all they're going to check. So as long as you can keep it organized, Matt, that's all that matters. Now, mine is really faded, so check that for me. Yeah? Okay, good. So just think of it, canceling. How do I get that to happen? Now, these last 2 are the ones that we feel bad about because we couldn't get to Chapter 9 with all of this goofy COVID stuff going on. We just couldn't get to Chapter 9. However, if we just remember 2 basic things about sequences and series, notice this is talking about a sequence here. Those 2 things are this. The names for them are and even this is goofy. Because when you look at this, you want to pronounce it arithmetic, right? It's pronounced arithmetic. because that's just what they do for sequences and series, arithmetic. But I want you to think arithmetic. So you have to think, which one of those is more basic? Is arithmetic more basic, or is geometric more basic? Well, you learned arithmetic back in kindergarten, for goodness sake. Here's an M&M. I'm giving you 2 more. How many do you have? So this is the most basic of the 2. And if it's the most basic, well, that has to be adding and subtracting, because that's the first thing you learned back in kindergarten. Geometric has to be a little bit more involved, because it took you a while to get to geometry, right? So this is multiplying. Now, if you're saying, well, why isn't that one multiply and divide? Because we can multiply by fractions, and then we don't have to divide. So write a rule for a geometric sequence with the first term of -4. So this is supposed to start with -4, and then we're supposed to multiply by something each time. That's called the common ratio. So what you'll see is this notation, and this notation means any term. To find any term, take -4 times -1/2, and it's to the n minus 1 power. And that's because if we put a 0 in here, we have to be able to get the very first term. Or if we put a 1 in, we have to be able to get the very first term. So that's what geometric sequences look like. We're going to learn them like this. A sub n equals a sub 1 times r to the n minus 1 power. Because they're going to do something like this, and then they're going to say, what's the 20th term? And you have to find it. So for this one, it says, what is the 8th term of the geometric sequence with the first term, so that's what they're starting with, -2/3, a common ratio of 3, that's what they're multiplying by every time, and to find any term, take -2/3 times 3 to the n minus 1 power, where n stands for the term you're looking for. So we have to put an 8 up here, because we're looking for the 8th term. So on the calculator, I would want to punch in 3 to the 7th times -2/3. Oops, wrong screen. And there it is, -1,458. All right, Cedarholm, I totally forget that fancy formula thing that you showed us from Chapter 9. Can I still get this answer? Of course you can. You could take -2/3 times 3, take that times 3, take that times 3, take that times 3, and do that 8 times, and you'll get -1,458. So your assignment for tonight is to get into, and I know you hate this thing, MCIS. You remember that from advisory? The one, okay, I can't say that on recording. The one good thing about MCIS is that it has a practice test section for the ACTs on it. So I want you to get in there tonight and play around on that and see if you can find those tests and start looking at them. That's your assignment.